Right. Hello everybody, my name is Markiplier and welcome to day 7, week 1 of revision. I am so sorry that I didn't do one of these yesterday. Honestly, I just didn't learn anything too notable that I struggled with. I'll be totally real with you guys. We did organic chemistry and I found it relatively fun, relatively alright. If you guys struggled with it, we'll go through it today, so don't worry. In case you're wondering what's behind me, this is my Choose Your Own Adventure, the work in progress Choose Your Own Adventure. This is it so far. We've just been kind of planning it out just now. Still a lot of branches left and stuff, but that is the Choose Your Own Adventure, which I will be making during the summer, which is why I probably won't be too active on this channel with videos, I'm afraid. So anyways, we'll start off by doing organic chemistry, the stuff that we did yesterday. And then what I'll do is I'll do the heart, and I want to talk about enzymes or like the digestive system. So we'll do a bit of biology, bit of that, and then maybe I might have time to do this thing in math, rearranging, which pisses me off. It's so annoying. It's so bloody annoying, and I've never liked it. It's the only thing in math that really pisses me off. Anyways, let's begin. So, I'm gonna go turn off this light, see if that maybe helps. Global dimming moment. Okay. So, organic chemistry, we have the alkanes, alkenes, alcohols, and the carboxylic acids. Those are the ones that we do. We also do esters, but I don't know what they are. He hasn't taught us them. Now, we need to know the acronym MEPB to remember the names of the first 4 hydrocarbons. So we have MEF, ETH, prop, and boots. So just remember MEPB, or monkeys eat peanut butter, that's the acronym. Alright, so let's go through every single one of these, and let's use ethene or ETH as an example. So that's 2 carbon and X hydrogen. So let's do this. So, how do we do an alkane of ETH? So it'll be ethane. How do we do that? Well, ethane is really simple. I don't know, you guys can't see that. Can you? Or maybe the bar's blocking it for me. Okay, ethane. Where's my rack? How do we do ethane? Well, that has 1 carbon, that has 2 carbon, that has 3, that has 4. So it's obviously just going to have 2 carbons, isn't it? And we can draw that like that, CC. Now, carbon has in its outermost shell 4 electrons. Okay, 4 electrons. How many does it need to complete its shell? 4. It needs 4 more electrons, because 8 total. Okay, so it can bond with 4 other things. Look, it's already bonded with 1, and it can bond with up to 3 more. And that's it. That's how you draw ethane. Literally just this. 2 carbon, and each one is bonded to something for the. Ethene, on the other hand, is identical except for one factor. Every single alkene, it must have a double bond of carbon. Alright, so how will this affect things, guys? How do you think? Well, look, that counts as 2 bonds, which means it'll only need 2 hydrogen in each one now. Nice. Alright, next, alcohols. Alcohols lose this double bond, so we can draw it like that, but I believe they also have an OH. Can't remember if that's... It might just be an O. I'm going to put it as an OH just to make... In fact, I have it on my phone, but I'm not sure if this will end the stream. Right, I'm back. And yeah, I was right. It was an OH. It has one OH bond. Everything else is fine. And look, that's bonded once, twice, thrice, 4 times. So that is perfect. Alright, now little practical question here. How do we get from that to that? Well, we add an oxygen, and we remove that carbon bond, and we add 2 hydrogen. We add water. H2O. See, oxygen, 2 hydrogen. Okay, but we need to break this bond. How do we do that? Well, I believe you use phosphoric acid or something like that. He hasn't explained it too fully to us, but I believe it's phosphorus something. And that breaks the bond. It's a catalyst. It speeds up a reaction. So our catalyst is that. And if you notice, H2O, in order for this to really have an effect, it needs to be steam. So it needs to be its gaseous form. Nice. We're almost done. All we need to know is carboxylic acids. What is an acid? Well, it is a substance which dissociates in water to give positive hydrogen ions. So let's put that knowledge to good use. Carbon, all right. So we're doing etholic acid. Okay. Now, the thing you need to remember, so next to each one, I'll draw what you need to remember. For alkenes, it's CC, double C bond. Alcohols, it's OH. For this one, it's COOH. Cool, basically. So carbon, oxygen, oxygen, hydrogen. Now, the way we would do this is, I believe, you would do C, or maybe O. Hang on. It's a weird way of drawing it. Let me go check. Hydrogen, hydrogen, okay. Hydrogen. Right, there you have it. This is it. That is it. COOH. Now you might be like, hang on Joseph, you're missing an H here. Because that's bonded 4, that's only bonded 3. You're correct. That should be OH. But in water, it disassociates to give hydrogen plus, so that'd actually be H plus, and we can get rid of that. What you're revising, I'm doing organic chemistry. I think I have a somewhat good understanding of it. So I think that's it. If you guys understand it, let me know. If not, Google Doc. You know the deal. Anyways, what I actually think I'm going to do today, and we'll do like that test at the end that I always do. So we can obviously test what we remember. I'm trying to find this book. I have so many bloody revision guides. Jesus Christ. That's biology. Yeah, that's the one. Okay. So, got the biology drip here. And our teacher does not explain stuff the best. To the point where I barely have learnt anything this year from biology. So I'm having to rely on my own kind of revision here to help. So I've already gone through the blood vessels in a separate stream. Trying to find the bit where it talks about the heart. Where is that? This is infection and response. Bro, where's the heart at? There it is. I hate this book because you have to bloody bend the spine of it. Literally me when I sit down. So he actually did a decent like diagram of this. He did it like a square type thing. But it's remembering. Oh my god, I'm really gonna have to draw it like this, aren't I? Okay. I'm not gonna draw a heart. I'm gonna draw like a box type thing here. So visualize the heart. So we have to go in the pulmonary artery. I'm going to draw it and then I'll kind of explain it, I guess. You have the, obviously, atrium and the ventricle. And then you have... That is... Oh, hang on, I've done it wrong way, right? Yep, I've done it the wrong way. The pulmonary artery is that thing there. This diagram's just a bit goofy, I'm not going to lie. Doing it as a bloody square, this is disorientating for sure. Hang on. Let me make this symmetrical for one. Okay, so those are the ventricles. That is the pulmonary vein. Right, please be the right way around. That is the aorta. That is the pulmonary artery, and that is the vena cava. Okay, right, yeah. Me one revision, right. So, again, I'm going to be totally honest with you and say that I don't really know the heart too well. I mean, I hope mine's doing well, but, you know, I don't really know it well. It's one of those topics, along with digestion, that for me just bores me. Like, it's I don't know, guys. I don't like it. So, it's a little painstaking to really remember, but basically, on this side, the blood goes in, deoxygenated blood, and then in this side, I think oxygenated blood comes out. Please say that I've done... Yeah, okay. Oh, and I guess you should probably label right and left. Don't know if you guys can see that there. And yeah, obviously in this side, in oxygenated. Alright, so blood flows into the two atria from the vena cava. So there are two arteries kind of connected to the vena cava that kind of flow into it. So ignorant. The atria contract. Okay, this is just kind of a cycle. We don't really need to know that. But basically, the heart contracts to pump blood around the body. We already kind of know that, right? So that's the diagram roughly of the heart. The only thing, I don't know what we would get questioned about in the exam, to be honest. Maybe we would get a 6 marker on explain the process of deoxygenated blood, or what side is stronger. I'm assuming the... No, hang on. Does it say here? I'm assuming it is. I can't remember what he said. See what I mean? I can't remember anything, bro. Seriously. Coronary arteries, I remember them because Miss Collinson See, anything that she explained, I remember. I seriously remember, but no. Oh, valves are obviously for backflow, but I think I've remembered. I think I said that in a previous stream. I think that's kind of everything. But it is the right side, right? Because that's the side with the arteries. So I'm assuming they would need to be thicker. If not, then I'll obviously remember that now. But I'm assuming we would probably get a question in the exam being like, explain the process of deoxygenated blood becoming oxygenated through the heart. And then what you would have to, well, not oxygenated, like beating through the heart. And what you probably have to say is it enters through the pulmonary vein? To the left side. Hang on. So it's this side in the diagram. Yeah, okay, so I was right. Sorry for oxygenated blood. So yeah, it enters through the pulmonary vein. Left ventricle is strongest. Right. So yeah, it enters through the pulmonary vein. Wait, no, it doesn't. You lying scumbag. Hang on. Hang on. This diagram's a little weird. This is. Okay, I can see. They've done it in reverse. So the pulmonary vein, it enters through there. It goes into the ventricule due to the contraction. It goes out through the. See, there must be a typo there because I know that's the wrong thing, bro. But either way, that's it. I don't like the heart for one, and the thing about revising it, it's a little annoying. I mean, I remember the names, but the order of the names is a little annoying. That's for sure. So I'm gonna probably just revise that solo using like Tassamai and stuff. That's probably one of the back burner questions, right? I mean, Mr. Hooper was saying, "Oh, I really hope it's the heart." I don't. I would rather it not be the heart. Thank you. Just looking through here, trying to work out what else I can revise in terms of biology. Because thing is, like, I bloody love biology, but the fact that we haven't had Miss Collinson is honestly tragic because I don't remember anything now. I barely remember the stuff she taught me, and I sure as shit don't remember anything Mr. Hooper's taught me, which is such a shame because it means I'm likely going to end up getting a pretty mediocre grade. And biology is probably the most, like, the subject we do least, I think, now, right? That's kind of a shame. Anyways, that's enough biology. I'll go do some, like, practice and stuff later. But I think for now, I'll do a general recap of everything that I've done in the last... Because it's been a week since we started. You guys might be getting rusty, I might be getting rusty. So I'll do a quick recap of everything we've done in the last couple of streams. And then from there, I might do one or two more biology things. Because that's what I was intended to do with this stream anyways, biology. But anyways, the first thing that I ever explained was how do you create a pure dry crystal. And let's just say that it's... magnesium sulfate. How would you make... Oh, I've done that E really weird. That's a T and an E joined. How would you make magnesium sulfate crystals? That would usually in an exam be a 6-mark question, which is pretty decent, honestly. That means you can get hit a lot of points just for explaining the bare necessities. So, for example, if you list the fact that your two products are magnesium oxide and sulfuric acid, I think that's 2 marks. So that's already a third of that done. Just for basically stating that you would add your sulfuric acid, you would heat it up, that's another mark, because to heat it up, you're increasing the rate of reactions. You would add Jesus Christ, you would add excess magnesium oxide, because what we're trying to do is use all of the sulfuric acid, so adding, of course, excess. So you would basically add magnesium oxide until there is only magnesium oxide remaining. And then what you would do from there is you would filter it, get rid of the excess, you would evaporate it, and then it will begin to crystallize, so you would leave to crystallize. And then if it specifies that it's a pure dry crystal, you can also pat it down with a towel. That is basically it. But you may not even need to add that much. I think you get 3 marks for saying that, a mark for saying that, a mark for talking about excess, 2 marks for that. So seriously, it is a simple process. And so long as you know what your products are, you should be reactants, sorry. As long as you know what your reactants are, you should be good. So let's think about all the other stuff we've done. We have done electrolysis. I'm not going to go dry it. My voice is beginning to go. Fuck. But this is, for example, in aluminium. an aluminium electrolysis, you have that, you have two positive anodes there, and then obviously you can specify that these are made out of graphite, and the fact that because oxygen goes to the anode, you can talk about how it creates CO2, which kind of wears them away, so they need to be replaced. You could talk about how the aluminium goes to there. You could talk about how it's in a molten solution. It uses cryolite to reduce the melting point. You could talk about, this is for example in an exam response where it's like, oh, explain how you would extract aluminium from bauxite. You could talk about how it causes the ionic compound to break down. It causes the lattice to break down. A bit like me whenever Luke Kelly messages me. And that's basically that whole thing. What else could you talk about? I mean, you could talk about how in molten or aqueous solution it allows for ions to move, but that's kind of it. I think if you were to get a 6-mark question discussing extracting bauxite, that's basically every point you need to hit. Regular electrolysis, remember the acronym, obviously positive anode, negative cathode. You could talk about oil rig, some reduction and oxidation. And I believe that's everything. I believe that's basically it. I mean, there's this annoying bit of like, oh, if it's an oxygen or a halide, or if it's like a group 1, I don't know. Didn't really fully understand what he was cracking on about when he was on about that, but either way, that's kind of it for electrolysis. I would argue it's one of the more unlikable topics, which is why I'm trying to revise it as much as possible, because the more I can revise it, the better marks I can get if it does pop up. And if it does pop up in an exam, I've discussed this in previous streams, but it could be worth up to maybe 5%, 4% of the whole GCSE. That's a lot just for being able to state some basic facts. What else? Neutralization, obviously just remember the byproduct is H2O, so that's 1 hydrogen there. Oh, OH, that should be actually, not H, but it doesn't matter. So that's an acid there, because acid disassociates in water to give H+. That's your alkaline, because it disassociates in water to give OH. And that is your product, H2O. Your product is also going to be a salt as well. What else? What else do we need to know for chemistry? The tests. Silver nitrate. This is topic 2, which we'll likely do with Mr. McAdam in a couple of like days, maybe next lesson. Who knows? Silver nitrate is used for halide testing, and you either get a white, cream, or yellow precipitate. That's either for chlorine, bromine, or iodine. Flame testing, you use something like a nichrome wire, dip it in your metal solution, and potassium is purple, copper is green, lithium I believe is red, and sodium, Na that is yellow. So markers run out. And the only other one we need to do is hydroxide testing. Those are like the big bulky ones. Hydroxide testing, you use, I believe, sodium hydroxide. So sodium. I like this one. It's kind of a black pen. Okay. Sodium hydroxide. And what you do with it is you add some in. If you add, so aluminium, magnesium, calcium, copper, and iron 2, iron 3. Okay, these 3 will give a white precipitate. However, if you add excess to aluminium, it will become clear. Copper is going to be blue, and copper 2 is going to be brown, copper 3 is going to be green. I think I may have mixed them up. let me go check quickly. I don't want to be telling you guys any misinformation here. This is all meant to be factual and helpful. And remember, guys, I have actually gone through this all. It was the other way around. Sorry about that. Everything else was right there. Oh, and I guess the proper explanation there would be that sodium hydroxide is used to test some metal ions because it forms an insoluble metal. So just talk about insolubility. Anyways, that's everything for chemistry. I'm not mistaken. I believe I am right there. So we've done everything there that I can revise well in chemistry. What else is there to revise, guys? What else? Well, let's do biology. We can do the blood cells, where the capillary is 1 cell thick, and that, of course, allows it to, oh God, what's a word? Not osmosis. Diffuse, Jesus Christ. Diffuse. See, I'm getting tired, guys. Diffuse. It allows it, ions to diffuse in and out of the capillary, out from cells in capillary. Arteries are thick and elastic because they require a high pressure. Blood flows at a high pressure because arteries take blood out of the heart. Veins take it in, arteries take it out. Arteries have valves to prevent backflow. And veins obviously take it into the heart. Deoxygenated blood into the heart, and arteries take oxygenated blood in. Alright, is that it? What else? Okay, I guess you could talk about, quickly, a bacteria. That thing there, these ring-like structures are plasmids, which are DNA rings. That is just a strand of DNA. And that is a flagellum, which allows it to move. What else? I guess we'll just go right back to where we were then, the heart. So, we have the atrium and ventricule, or I call it atrium and vent for short, I guess. We obviously have, that goes out, that goes in, that goes out, and that goes in. Hang on a minute, I might need to pause here. I've been muted this whole time. Fuck. Oh, I'm so sorry, guys. I'm so sorry. Shit. I've been muted for 8 minutes. Fuck. Wait, am I? Alright, I'm so sorry about that. All we talked about were the food tests, the lungs, where I talked about air sac. Shit. Bollocks. Been muted for 8 bloody minutes. If you guys want me to go back through anything that I've just talked about there, let me know. All I did was I did a quick review of the food tests. I went quickly through the heart again, and I just talked about how the alveoli are adapted to do their function. I'll be right back. I'm going to go do math. I want to do a question. Oh man, I'm honestly crying at that. I'm so sorry, guys. Didn't realise I was muted for 8 bloody minutes. Anyways, this is a math question that really pissed me off today because I couldn't do it. And I know what you do, I just didn't have the time to do it. You have to make M the subject. Now, how would you go about doing that? Well, obviously you would expand these brackets out. So 4 times 2, so surely that would be 8m. And then that, 4 times minus 1 would be minus 4. Alright, so we got 9m plus 8m minus 4 equals p squared plus pm. Alright, we can combine these because they're like terms. So that would be 17m minus 4 is p squared plus pm. I guess now we can do that to add 4 to that side. I think. Is this allowed? And then surely you would just divide by 17 to get m as it on its own. Or wouldn't you divide by 17m actually? So m equals... that can't be it. This can't be it. Let me go Google that. I'll be right back. With a tad more insight. Alright, 17m is... See, I thought you would have just divided by 17. Surely that would give you the answer, but apparently not. Apparently you have to do it this dead other way. So apparently if you take away pm, you get 17m minus pm equals p squared plus 4. And then I'm assuming, what? You could take away something? You could add p? To get p cubed? You can't do that, right? Because it's a group term. You can't minus 4 because we just minused 4. Would you divide by m maybe? But then you're not making m the subject, you're making 17 the subject. If you divide by 17 maybe. Alright, let's try it. If we divide by 17, we get m minus pm, so you would add pm. But that's still wrong. According to Google, that is still the wrong answer. So yeah, I'm not sure what you would do there, guys. Seriously, not sure. So, is it working? Okay, we're back. I googled, there's no answers anywhere for this question, so I am quite literally stuck. I don't know if that's the right one or the wrong one or what you're meant to do there. I mean, I thought my solution to begin with was fine, because you've got m on its own, but I don't know, is that meant to be something different? Am I meant to square root it, maybe? You guys are going to have to let me know that, because I don't know. I feel like I've done this totally wrong, and yet I have no way of confirming if I've done this right. I mean, what did I do? I did 17m minus m over p? So I must have added minus pm much earlier. And then divided by p, which just doesn't make sense, and then multiply by 70. Doesn't make sense. So yeah, that's the only bit of math that still annoys me. I can complete the square, factorise, expand triple brackets. Circle theorems piss me off because I hate them. Inverse proportion, I kind of get now. That's the only thing that I don't like about math. Only thing is though, I don't think that would actually appear in the exam anymore, or it would probably be one of the last questions. This was like question 18. And it was only worth 4 marks. 4 marks for that, man. When you have way more easier questions that are worth 6 marks. So I would honestly, if that was in an exam, I would personally just skip that. Or I would do what I got up to. I would expand the brackets for 1 mark, but that's all I could probably do. I probably couldn't get any further. So anyways, that's all I'm doing for today, guys. Apologies that I was muted halfway through. I'm going to go now because I'm tired.